What's up, guys? Today we're going to talk about data science buzzwords. Artificial intelligence, machine learning, big data. Is it all just nonsense? What does it mean? Let's take a look. So hopefully by the end of the video, you'll be able to see how these topics relate to each other and how they form kind of a data science pipeline, and how you move from data sets to machine learning tools and finally to AI products. All right, so the first term we're going to talk about is machine learning. Now, machine learning is really just kind of a buzzword for a set of computer algorithms that take data and map it to some kind of outcome, right? And that outcome can either be a number, like how tall somebody is or how much they weigh, something like that. We call those regression algorithms. On the other hand, we have classification algorithms, which take data and map it to some kind of number of categories, like dog, cat, horse, plane, something like that. For image recognition, a few years ago, somebody made an algorithm that does, is this legs or hot dogs? But these are all kinds of machine learning algorithms. Basically, the core idea is that we're going to take some data and we're going to map that to some kind of outcome. Usually, machine learning algorithms work by kind of guessing and checking really fast, right? Like you might do on, when you're a little kid and you learn math, you kind of do this guess and check to see if you got the right answer. That's basically how machine learning algorithms work. They need some kind of component to, make a guess, right? So if you're trying to guess how tall somebody is or something like that, you first have an algorithm that takes data and puts out a guess to how tall the person's going to be. You need to check to see how off you were, and then you need some kind of update mechanism to take your guess and make it just a little bit better. And really, the power of machine learning algorithms is that they can take this kind of guess and check and update loop and do it really, really fast on a computer. So machine learning is kind of the general term for these algorithms that can kind of map data to outcomes. But you'll also hear a lot about the specific kinds of machine learning algorithms. There's things like neural networks or decision trees that are really just specific strategies for doing this kind of guess and check and update loop, right? They do the same thing. They're just different ways of kind of attacking the problem. And the reason why we have multiple machine learning algorithms is each algorithm kind of works in a little different way, and there's not one that's completely better than all the other ones. So a lot of times what data scientists do when they're working on a problem is try a bunch of different kinds of machine learning algorithms to find which one works best on their particular data set. Next, let's talk about deep learning. Now, this gets talked about a lot. You hear kind of, it's one of the main buzzwords in data science. It's really popular because big tech companies push, deep learning, and you'll hear, Google uses deep learning to power a lot of their services, like translation and image recognition, stuff like that. Deep learning is really just a family of machine learning algorithms. They're also called neural networks. They're a type of neural network algorithm. So the main advantage of deep learning is that it's really efficient at taking data and mapping it to the outcome without having to worry so much about how your data is structured ahead of time. A lot of machine learning algorithms are very picky, and you need to make sure your data is structured in a very specific way so that they can easily map it to the outcome you're interested in. Where deep learning really shines is that you can kind of just throw, if it's raw images or raw sound data, something like that, straight into it, and it'll come out with a good mapping for you. The trade-off to this is that you need a ton of data to get this system to work correctly, and it's also really computationally intensive. So you need big servers, lots of graphics cards, you think about cloud computing. It really takes a lot of money to set this stuff up right. But if you have that, like a lot of these big tech companies have that infrastructure set up already, it really cuts down on the amount of human intervention that you need to hand design your data set and make sure that it works well. You can kind of just trade human time for computer time, which is what a lot of companies are looking for because computer time is a lot cheaper. All right, next up is big data. Now, there's not really one definition of what big data is. I mean, it's mostly just kind of a marketing buzzword kind of thing. Some people say big data is any data set that doesn't really fit on your laptop or your desktop computer, or maybe it's data that doesn't fit on like a single server, that you might use at work or something like that. Those are reasonable definitions insofar that there is a definition, but honestly, companies like AWS that provide cloud computing services are making bigger and bigger servers available to the general public for basically pennies an hour. On the other hand, people are generating more and more data every year, so kind of what constitutes big data now is pretty tiny compared to 5 years ago or even last year. So really the definition of big data is not static. And people, I think, just kind of generally use the term to refer to a large collection of data. All right, and last up we have AI, artificial intelligence. This is probably the coolest sounding term, but it's also probably the most made up term, right? There's really nothing like artificial intelligence like you see in the movies, right? Like you watch The Terminator, you watch 2001, there's these kind of robots that are generally intelligent like people, and obviously in the movies a lot of times they turn evil and try to kill the hero or whatever. That doesn't exist currently. It's not a real thing. People use AI mostly, I think, to kind of hype up their products and make them sound really cutting edge and cool. Insofar that AI does exist, I've heard some people kind of define it as machine learning with a front end attached to it so that it kind of tries to mimic a human interaction. So you can think maybe like a chat bot might be considered AI because you type something into the chat window and the computer answers you and they try to pretend like they're a human, maybe like a support chat bot kind of thing. I mean, that's a reasonable definition. Mostly you can kind of not worry about what AI is because most of the time when you hear the term, it's kind of just sales and marketing rather than an actual category of thing that data scientists spend time worrying about. But it's definitely not the Terminator. It's definitely not, generally intelligent. There's no machine learning tools that are smarter than people or even close. So this is probably one of the biggest buzzwords out there and kind of one of the most irrelevant when it really gets down to brass tacks. All right, so there you have it. Those are some data science buzzwords that you may have heard before. Hopefully that does a little bit to clear up what do these terms mean. Hopefully you got a little bit of understanding on some of the kind of more important ones like machine learning and deep learning. And also you kind of learned which ones to kind of avoid or ones that don't really make any sense like AI or big data, things like that. So, if you have any more questions, let me know down in the comments. Don't forget to like and subscribe and see you next time.